Alright, so this last lesson, which is lesson 5.6, this is only part 1. There's a part 2 that kind of pulls all this information together and forces you to use all the concepts that we have. We have we have the vertex form, the standard form, and the intercept form, and all three give us bits and pieces of information. So for example, let's go and take a look at example 1 here. Now it's asking you for each relation you need to express the relation in intercept form and zero and find the zeros. Then you're going to provide a really rough sketch of what the parabola is showing, what the parabola looks like, and show the zeros and the axis of symmetry. Notice we didn't ask you for the vertex. Alright, so let's begin. So remember, when we're finding the intercept form, that just tells us that if we have the standard form, like we have right here, we must factor it, okay, and then find the zeros. Now, the intercept for our graph is given by this standard equation, y is equal to 2x squared plus 4x minus 6. The minus 6 is the y-intercept, so we can easily plot that on our graph to be minus 6 somewhere down here. So now we have our first point that we can use and mirror in our axis of symmetry. Now, the axis of symmetry usually depends on the vertex of the parabola. Now, if there are two points, i.e. two x-intercepts on the x-axis, right, like either here or here, or over here or here, what that will do is will give us an idea of which way the graph is going, because in this case our y-intercept is below the x-axis, right? And that might tell us that our vertex is down here, is actually somewhere below. So let's continue. Now, when we factor, you have to pull off the 2 and then divide all of these numbers by 2 to get 2x squared plus 2x minus 3, right? And then when you factor accordingly, using all of your steps, you're going to end up with 2 bracket x minus 3 and then x minus 1. Now, that tells us what our zeros or x-intercepts are, right? In this case, we're going to have the intercept form, which means that we have minus 3 and 1 for our zeros, right? So we can plot them on our graph and then draw our parabola. And if we want to, we could draw our axis of symmetry on this graph. Now I'm having issues getting my points to pop up on the graph, so don't worry about it. When you graph it, make sure that you draw your axis of symmetry exactly halfway between -1 and 3. Now, we'll do the same for this other graph, and you'll notice all this information gets calculated the normal way. Pull off the -0.5, divide everything by 0.5, and you end up with this, which means this is the intercept form, which means your zeros are 5 and -1. Remember, 5 is opposite of -5 in the brackets, and -1 is opposite of +1 in the brackets, which means these are our points. Now, if you don't care about the points, just immediately and go put them on the x-axis. Okay? Alright? And those are the points. So now that you've got the basic points, all we need now is the y-intercept, which we easily calculated earlier to be 2.5. So we could plot it right on our graph right away. And since we have that, we can use it to help us kind of graph what our graph looks like. Okay? Now, I didn't put the axis of symmetry. You guys should do it. Now, to find the axis of symmetry, we have to add both intercepts and then simplify the top. So in this case, I have -3 plus 1 gives us negative 2 for the first one, all divided by 2, which gives us negative 1. So now that I know what my axis of symmetry is, I can take that and graph it on my parabola. And I should be able to do the same for the other equation as well. Right? And that's it, really. And then from there you can go and just sort of draw it if you want on your graph. Okay? Now, the first graph, I had all these points that were supposed to pop up, but they're not showing up properly, so I've kind of given up. I'll just draw it and move the graph over. Okay? So there is x is equal to negative 1, and I can't find my other axis of symmetry. It's giving me grief. And then we have x is equal to 2. So just kind of draw it. So now, let's move on to the axis of symmetry of the relations that we have on this problem here. So the key idea is we need the intercept form, and then we find the axis of symmetry for both of these. Okay? Now, in this case, a is 1. Because a is 1, this is a minimum, not a maximum, right? We need to factor this equation, so this is how we factor it normally, and we end up with 5 and 11, and it's plus and plus, and so these are our x-intercepts, or our zeros, okay? So you can write x is negative 5 and that, and those gives us some points if we wanted them. Now you don't necessarily have to put the points, you just tell me what the x-intercepts are, or the zeros, they're the same thing. Then I need you to calculate the axis of symmetry. The axis of symmetry is just the average of two numbers that you came up with. And that gives me negative 6 over 2, which gives us negative 8. And now, once I have my axis of symmetry, okay, the next thing that we have to do, if we wanted to find the maximum, we just plug those numbers, we plug negative 8 into this equation here, our original factored form. And that makes the calculation really easy because it ends up just being two straight numbers multiplied together. And you know you got it right if, when you simplify the brackets, you have, in this case, minus 3 and then plus 3 multiplied together to get your answer. Okay? Alright. And in this case, we end up with negative 9. Alright, so the vertex is negative 8, 9. So now they've asked us to go and calculate the vertex form. Now remember, the original equation was 1x squared plus 16x plus 55. So that's what our a value is. Once we find our vertex with our axis of symmetry and y is negative 9, our minimum value, this allows us to go and use this basic equation to go and set up our solution. Now remember, if I have a vertex of negative 8, inside my bracket is going to be positive 8. And then we just copy down the 9 from our the negative 9 from our vertex, and we are done. Now, let's go on to the next problem. So we have this problem, so we factor it. Now, before we move on, anytime I have 4 and an x with no bracket outside, all that means is that the 0 or the x-intercept is 0. Okay, and we still have x minus 6, and we get the opposite of that to get positive 6. And those are the possible points on the graph. But now let's calculate our axis of symmetry and our vertex. So let's go. So you simplify by adding 0 plus 6, hit enter, and then divide by 2, enter. and that gives you x is equal to 3. So now, if x is 3, we're going to plug it back into this equation, okay? Or the original, it's up to you, and you end up with y is 36. So, in order to come up with our final equation for our parabola, we have a is negative 4, because the negative 4 is on the x squared term, and then we have x minus blank. It's going to be, since it's plus 3 here, it's minus 3 in the brackets, and then our y value becomes plus 36 on the outside of our bracket, and we're done. Alright, so let's consider this relation, right? Does this relation have a maximum or a minimum value? Right, in order to figure that out, we have to look at the a value. In this case, it's positive, so it opens up, right? Okay, now remember, stuff opens down if it's negative, if a is negative, right? Now, it is a minimum. So now we have to find the maximum or the minimum, right? Now, you'll notice that this value is the y-intercept, so it's not too bad, easy. So, right now, for our equation, when we're finding the maximum or minimum, we have to find the axis of symmetry. So that's why we are going to find the intercept form. So right away we have to pull off a 4 from everything in here. And that's why we have 4 times this junk inside the brackets. And how did we get that? We divided each of these terms by the number 4. So now let's continue. So now we have to find the factor, right? So we got to find a number that multiplies to 65 but adds to negative 18. And we're going to go through a whole bunch of it. So we start with 65 and break it down to 1 and 65. Then we try 2 and then 3 and then 4 and then, 5 works, right? And so 5 times 13 works. That might be what we're looking for. Now, remember that we have positive 65, so we can either have 2 positives or 2 negatives, right? For our multiplication, which means this number, negative 18, comes about because of having us have negative 5 and negative 13 happening at the same time. So now let's begin. Let's fill that in, and we're going to put in minus and minus. And that tells us our zeros, or our x-intercepts, are 13 and 5. So now let's calculate our axis of symmetry. So remember, our axis of symmetry is the average of the zeros that we have here. So now what that means is we're going to go and take 13 and 5. We're going to add them together, get 18, and then divide by 2. Okay? So now x is 9. So we've got the x value of our thing. So now we need to calculate the y value. So if x is equal to 9, all you're going to do is plug it into our factored form to get negative 64. So the vertex of our parabola is 9, negative 64. Right? Which means our vertex form is that. And it opens up, and its y-intercept was determined before to be 260. Now that would be crazy for us to kind of graph that. So let's just sketch it. Right? So if you sketch it, just draw a line, draw a thing, put its vertex on it, put all the zeros on, the zeros for the x-axis and the y-intercept, and then if you can, put the vertex in too, and you're good to go. Okay? So that's pretty much it. Alright? Now, let's do question number 5, and then we will move on to, I believe, question number 6. So this problem has zeros at negative 1 and 11, right? So this means the equation, we want to find the equation in intercept form, standard, and then vertex. So The zeros are -1 and 1 and 11, right? So if I was looking at this parabola, it passes through 3, 8. So how the heck are we going to find the a value, which is missing, right? So what you're going to do is you're going to write your equation in intercept form, okay? In intercept form, you're going to write it as this. Y is equal to a x plus 1, x minus 11. And that's why we're using these zeros, right? And now that we've got those zeros plugged in here, we're going to use this 3, 8 to help us find this a. The x is going to be 3 in these two brackets, and the 8 is going to be the y, and then we will solve for a. So now, when we do our substitution, we're going to get something that looks like this. So when we substitute the x and y into our equation, we have 8 equals a, 3 plus 1, 3 minus 11. Now you got to remember, if you can't remember that x and y are the 3 and 8, just write over top on your sheet and then just plug it into your equation that you have here. So now we simplify this bracket, simplify that bracket, and we end up with a is equal to 4 times -8, all times a equals 8. So now we're going to bring these two numbers together to get -32 and then put the a behind, and then we have to solve for a. And in order to get a, all you have to do is just say a is equal to a divided by -32, which turns into 0.25, which means that this is our intercept form. Okay, so all we did was just plug in what we had. So now for the vertex form, let's calculate the axis of symmetry. So the axis of symmetry is going to be -1 plus 11, which is 10 over 2, which gives us 5. And now we're going to calculate the y value for our vertex. And we end up with y is equal to +9. And you notice we took our 5 and we plugged it into this equation that we just calculated. Best thing ever. And by doing so, you get +9. So from here, we can go and write our vertex form. And our vertex for that equation is going to be 5, 9. So now the vertex form is simply this. Okay? Now remember, the 5 is opposite inside the bracket and the 9 is the same outside the bracket. So we've done the intercept form, we've done the vertex form, and finally, I think we may have to do the standard form. Maybe. But the standard form, all you have to do is expand the vertex form and you're done. Okay? And I think we are done. So I'm not going to do the expansion because we've done that to death. Okay? Alright. We're done. You can work on the problems that I've provided for you.